Hello student. Today's topic standard error. Standard error of small y bar is defined as variance y bar. In order to estimate the standard error on simple option is to consider the square root of estimate of variance of sample mean. Under SRSWOR, a possible estimator is sigma y bar equals to root over capital N minus N by N in S. And under SRSWR, a possible estimator is sigma y bar equals to root over N minus 1 by N in S. It is to be noted that this estimator does not possess the same properties of variance y bar. Reason being, if theta dot is an estimator of theta, then root over theta dot cap is not necessarily an estimator of root theta. In fact, the estimator sigma y bar is a negatively biased estimator under SRSWR. The approximate expression for large n case as follows. Consider as an estimator of capital S. Let small a square equals to capital A square plus xi, where e xi equals to 0 and capital E xi square equals to capital A square. Now we can write small s equals to capital A square plus xi whole to the power half, that equals to capital S 1 plus xi by a square, xi by a square equals to 1 by half, that equals to S 1 plus xi by 2a square minus xi square 8 is to the power 4 dot dot. The result for the unbiasedness property and the variance of sample mean can be also be proved in alternative way. Now for SRSWR, let a random variable AI associated with the ith unit of population denotes the number of times the ith unit occur in the sample I equals to 1 2 dot dot n. So AI assume values 0, 1, 2 dot dot n. The joint distribution of A1, A2, An is the multinomial distribution given by. Now P A1, A2 dot dot An equals to n factorial I equals to 1 to n ai factorial 1 by cap n to the power small n, where summation I equals to 1 to n ai equals to small n. For this multinomial distribution, we have capital E ai equals to small n by capital N. Variance ai equals to n minus 1 by n square I equals to 1 2 dot dot n. Aj equals to minus n by n square I not equals to j dot n. Now we rewrite the sample mean y bar equals to 1 by n summation I equals to 1 to n ai yi. Hence, taking expression of y bar and substituting the value of e ai equals to n by capital N, we obtain that e y bar equals to y bar. Now, determination of sample size. The size of sample is needed before the survey start and goes into operation. One point to be kept in mind is that when the sample size increases, the variance of estimator decreases but the cost of survey increases, and vice versa. So there has to be a balance between the aspects. Now, the sample size can be determined on the basis of prescribed values of standard error or sample mean. Error of estimation with the confidence interval coefficient of the variation of sample mean, and relative error or sample mean or total cost among several others. The next topic, pre-specified variance. The sample size is to be determined such that the variance small y bar should not exceed a given value, so capital V. In this case, find n such that variance y bar less than equals to capital V, or capital N by n y bar less than equal to V, or n minus n a square less than equals to V, or 1 by n minus 1 by capital N less than equal to capital V by a square, or 1 by n minus 1 by capital N less than equals to 1 by ne, that n greater than equal to ne 1 plus ne by capital N, where ne equals to a square by V. Next, pre-specified estimation error. Okay, pre-specified estimation error. It may be possible to have some prior knowledge of population mean y bar, its capital Y bar, and it may be required that the sample mean y bar, its small y bar, should not be differ from it by more than a specified amount of absolute estimation error. That is, which is a small quantity. Such requirement can be specified by associating a probability 1 minus alpha with it can be expressed as P y bar capital Y bar its small y bar minus capital Y bar less than E, that equals to, we can write 1 minus alpha. Since y bar follows n capital Y bar n minus n a square, assuming the normal distribution for the population, we can write P small y bar capital Y bar, put in mod variance y bar less than equals to E by variance y bar 1 minus alpha, which implies that E by root over variance y bar equals to z alpha by 2, or z square alpha by 2 variance y bar equals to E square, or z square alpha by 2 n minus n by nn a square equals to E square, or small n z alpha by 2 by E s whole square 1 plus 1 by n z alpha by 2 s E square, which is the required sample size. If capital N is large, then small n equals to z alpha by 2 is by E square. Okay. Pre-specified width of confidence interval. If the requirement is that the width of the confidence interval of small y bar with confidence coefficient 1 minus alpha should not exceed prescribed amount, it's W. Then the sample size small n is determined such that 2 z alpha by 2 variance y bar less than equal to W. Pre-specified coefficient of variation. The coefficient of variation CV is defined as the ratio of standard error and mean. The knowledge of coefficient of variation has played an important role in the sampling theory, as this information has helped in driving efficient estimator. If it is desired that the coefficient of variation of y bar should not exceed a given or prescribed value of coefficient of variation, say CO, it's like CO or C0, then the required sample size small n is to be determined such that CV y bar less equal to C0 or variance y bar root over y bar less than equals to C0.